Hey everyone, and welcome to this explainer brought to you by Forge College. If you're joining us today, congratulations! You've officially survived the complexities of resource management, and you're now staring down the barrel of a live deployment on the Solana blockchain. Think of this whole process exactly like an aerospace pre-flight launch. I mean, you wouldn't just strap yourself into a giant rocket, blindly smash the big red button, and just kind of hope for the best, right? No way. You need a meticulous, rock-solid pre-flight sequence so you don't accidentally blow up on the launch pad. So today, we are going to build that exact sequence together. Okay, let's dive right into this. In our previous lesson, we were totally deep in the planning zone, working out our estimations and spitting out a super handy JSON report. But as we know, estimation is really just theory. Today is the day we bridge that gap. We're moving from simply estimating those resources to actually executing a safe, successful launch. We're taking our theoretical map and turning it into a concrete, executable reality. Here is our essential pre-flight manifest for today. We'll be covering from estimation to execution, generating the checklist, the three-phase workflow, the go-no-go decision, post-deployment tracking, and wrapping up with next steps and takeaways.
All right, section 1, from estimation to execution, fueling the launch.
So if our deployment is a rocket, our data is literally the fuel. Remember that token swap JSON report you generated back in the previous lesson? Yeah, that wasn't just busy work. We're actually looking at specific fuel types from that report. We've got compute units, where we're comparing our measured maximums right up against our recommended thresholds. Then there's storage, where we're checking measured bytes versus what we've actually reserved. And of course, transaction fees, where we match our estimated totals against the budget finance actually approved for us. We're taking these very concrete numbers and converting them into strict, non-negotiable, pass or fail conditions.
Moving on to section 2, generating the checklist, the automation engine.
All right, now that we've got our fuel, we absolutely need an engine to transform those static numbers into actual action. Enter automated gating. This incredibly useful concept uses machine-readable pass or fail flags to automatically block or allow your deployment pipeline based on explicit thresholds. Why is this so important? Well, because it completely removes human emotion from the equation. When you're running on fumes, heavily caffeinated, and just trying to rush a Friday afternoon deploy, automated gating doesn't care. It just reads the cold, hard data, keeping your deployments consistent and, frankly, infinitely safer.
And this brilliantly illustrates how it works under the hood. Our Node.js generator script basically acts as a scale. It looks at your measured values, like, say, your maximum compute, and compares it directly to your threshold. Are you under the limit? Perfect, it kicks out a Boolean true. Are you over the limit? It spits out false. It really is that simple. This strict mathematical comparison gives us a totally deterministic flag that we can feed directly into our continuous integration pipeline.
Section 3, the three-phase workflow, our pre-flight sequence.
Having a generated checklist is fantastic, but you need a very strict chronological blueprint for using it in your staging environment before you ever dream of touching mainnet. You've got to treat this exactly like a multi-stage rocket ignition sequence. Phase 1 is verify artifacts. Phase 2 is run automated gating. And Phase 3 is convene the go/no-go meeting. If you try to skip a phase, well, that rocket stays firmly on the ground. Let's quickly zoom in on Phase 1, the verification of artifacts. This strictly requires your file checksums and your CI build artifacts to perfectly match expected hashes. No exceptions. This phase only passes if your compiled program size fits perfectly within the estimated storage bounds we defined earlier. If that binary is suddenly bloated, nope, the launch is scrubbed immediately.
Section 4, the go/no-go decision. Welcome to mission control. Now, assuming your automated gating passed with flying colors, it's time to assemble the team for Phase 3. This is mission control, that slightly sweat-inducing moment where humans actually have to look at the data and make a final call. What's really interesting here is how this official ledger maps every single piece of required evidence to a specific responsible role. The engineer has to sign off on the compute budget, the build engineer verifies the binary checksum, DevOps sounds off on storage allocation, finance approves the fee budget, and QA provides the test results. Everyone has a specific piece of evidence they must bring to the table to get a go for launch. And, well, take a look at this massive 0 right here. Why? Because 0 is the exact number of critical test failures allowed by the QA team at the 11th hour. 0. Zilch. Nada. If that test suite spits out even a single critical failure, we pack it up and go home for the day.
Which naturally brings us to the golden rule of critical deployments. A launch always requires at least 2 approvers turning their keys at the exact same time. typically your technical owner and an operations manager. And listen, if any of those automated flags from phase 2 show up as false, it's an automatic no-go, the launch is scrubbed until corrective actions are taken, properly documented, and the entire sequence is run again from the very top.
Section 5. Post-deployment tracking, or what happens after liftoff. Look, just because you finally clicked deploy definitely doesn't mean your job is done. Actually, getting the program onto the blockchain is really just crossing the starting line. Once we're actually in orbit, we need to collect successful program initialization logs. We need to verify that our on-chain account sizes perfectly match our pre-flight estimates, and we absolutely need to observe our initial transaction success rates. Tracking these specific metrics builds up a historical data set, which is amazing because it helps us tune our thresholds so that our future deployments are even smoother.
And finally, Section 6, next steps and takeaways, closing the loop.
So let's bring all of this together. We've gone all the way from theory to automation to human review and finally to post-launch tracking. And the crucial takeaway is right here. Every checklist item must be traceable to a measurable artifact. Seriously, if you can't measure it, you simply can't put it on the checklist. This strict traceability is exactly what makes your deployments defensible, automatable, and above all else, incredibly safe. Which leaves us with one final absolutely critical question. Are you actually ready for mainnet, or does your data loudly say you still belong in DevNet? The blockchain is pretty unforgiving, but with a finalized, repeatable checklist, you now have the exact tools you need to let the data make that tough decision for you. In our next lesson, we're going to dive deeply into environment selection. Until then, make sure to head over to forge.college to explore more deep dives and keep refining those Web3 skills. Thanks so much for joining me on this explainer, and I'll see you in the next one.